Alright everyone, so welcome back to my channel. Today we're gonna do a problem find the index of the first occurrence in the string. Find the index of first occurrence in the string. This one is a pretty easy problem. So let's say we just have one is a really easy problem, right? So let's say we have a needle right here. Why I got this right there? I don't know. Let's say I got the needle right here. This is just the needle, right? We have a haystack right here, and we just need to find this substring. I would say substring inside of this haystack. So what if I have an integer like a, b, and then right set, and then but set, right? And I have another. I have this hat right here. What I just need to do is I maintain the window of length set right here, and then I move my window, right? So I move my window, I move to this portion. And I compare the BSA right here with a set. It's not that, so I move it right here, and then I compare this. It's actually equal. So since this is equal, we return the index here, right? So this is easy. However, since we have to maintain a window, it's gonna cost us O of n time complexity, right? And it's also need to multiply with the cost of this needle length. I call it m, right? And we don't want to do an easy problem, we want to do a hard problem. So I want to eliminate this comparison, because when you compare two string, right, it would be, when you compare two string, it would be you have to compare its character in the string, right? So you loop through that string, it would be the length of the string. So to solve this problem, we have to use something called rolling hash technique, and it's not going to be super easy, but just follow me right here. So let's say you have imagine you have a base 10 number, right? So 1 2 3 right here, right? What if you want to remove the 1, right? If you want to remove the 1, you have to subtract, maybe let's do 273. You have to subtract the 2, right? 2 times the 100, right? You have to subtract this amount, right? So 73 to get this one, right? And for this one, you have to, if you want to add 4, right, you have to just simply multiply 73 with the base 10, because it's base 10. This number is in base 10, so this base is 10. Multiply with 10, then we add 4. Let's say we want to add 4, right? So then we add 4 in here. So in here it will be 3 to 4, right? This is similar to this problem, right? So to cut off the head, we multiply with the 100. To add this in here, we need to multiply with the base and the 4. So is it, right? So let's say, what if the length of, as I shared before, I have 2 5 7, right? The length of this is 3. What if the length of it is 4? The length of this window side right here is 4. You have to multiply with 1000, right? So this is base of 10, right? And then this is 1000, yes, but the length of it is 3. So 10 power of 3 is gonna be 1000, right? So this is where the base in case where we get the formula, right? So we have to do this. The formula is to chop the head off, right? First, we have our window, right, minus the base plus what the fuck. So the formula right here is, let's say we have our window, right, in a hash function, right? We have to take that window to subtract whatever value it is, 2 3 whatever, right? Subtract the value, then you multiply that with the let's just go down here, right, with the base, and then power of the length of the current window, right? Length of the current window minus 1. So this is where we chop off the head, and then we have to add value in the base, right? Add value to the window. It's just simply window you times with the base, then you plus value right here. So this is the formula to slide a window, right? And when I talking to the numbers right here, this is base 10. It's similar to base 26 because all of this lower character is 26. So it's similar to base 26. And however, I will use base 31 because this is the prime number. And sometimes when you have to base 26, the numbers get really big, so you have to mod with 10s over 9 plus 7, right? 10 power of 9 plus 7. So sometimes it's gonna have a collision. And that is the reason. So then when you convert a window to a hash kind of base, it's gonna have the same hash. So to avoid collision, I'm just gonna use 31. And I also have to need to check for collision. And yep, and let's just trying to code that out. It want to make more sense to when you code it up. So let's say right here I have simple. I will have my n right here, which is the length of the haystack, right? I will have m is the length of the needle, right? So if m is greater than n or m equals 0, so this is just the base case. We'll just return 1. We don't find anything. As I said, I have my base is 31 and I have my modulo is 10 power of 9 plus 7. This is big numbers used to mod. I will have my character to value function. So let's say return ordinary of the character, ordinary of a plus 1. So we just do this because we plus 1 in here because we don't want to have 0 character value. I want to have 1 value, or would be equal to 1, b would be equal to 2, something like that. So I just don't want to hold 0 value in here because it's gonna mess up our math. I will also have a multiply, right? I'll just call it multi. It's just basically we get our base and then minus 1 and minus 1. So this is our base. This is the m minus 1 is the length of the window, right? Length of the needle. B times length of the needle. And then the mod, this is used to chop off the head of the window, right? So, right. And then in here we will have our parton. We have our parton hash, right? Parton hash is gonna be 0, and then also our window hash. So this window we use to slide in the haystack, and our parton hash is our target. Let's call it target, just to target, right? So I will loop through for I in range. I will loop the first 3 character to build the window hash and to build the target hash. So it's just simply the formula is just the same. So because parton hash multiply with the base, right? Then plus the character value of the needle in I, and then the same thing for window. So window hash, we have a needle right here, so this is haystack, right? And then all of these we have to mod it by the mod. So we have to mod it because it's gonna be a really big number. All right, since we mod it like this, it's just simple. Boom, add another one. It's just simple like this, right? Because we have a base. Then for I in range of the n minus m plus 1, right? This is we will take the first 3 character, but because not like this, should be like this. Yep, the first few character. Let's say we are at the s right here. If we try to go further than that, we will be outbound. So this is just help us not being outbound. So we do that, and then let's say if our window hash, right, equal to our target hash, and we also need to check if the current I plus the m equal to the needle. This is for collision. As I say, sometimes the actual window hash and the target hash will have the same value. So this is just to make sure that it's actually got that each case, as I said. So if I is smaller than n minus m, right there, we just need to have a character out, right? We have to cut the character in the front. So haystack of I, and then we need to have a character in is n plus m. So our window hash right here. So this is where we take off character. So to take off character, window hash would be minus the base. Oh, my bad. Minus the like this. Minus the multi with the character vowels, right? Character vowel of the C out, right? C out multiply with the character out and the mod. Then we add a new character in. So just simply do this, right? Multiply with the character in, something like that. And we multiply with the mod at the end. Let's say if sometime when we mod we have a negative number. If it's negative, we just window dash plus equal mod, and at the end we return -1 if we don't find anything, if we don't return anything in here, and that should be it. Yep, should be it. Let's just try to run it, see if it's work. Sometimes it's not work because misspell. Yep, now it should work. As I talk about the time complexity, this one is called actual of n, which is the length of the haystack, and the window and the space is also of 1 because I don't use any other array. I just use values to represent a value to represent a window. So okay, thank you for watching and see you soon on the next video.